Alright guys, if you are in the market for a suppressor wrap, give Rock Precision some consideration. This is their Tactical Freedom Wrap. Everything's made in-house by them. Veteran-owned company. They can do custom work. Go ahead, look them up. Paul over there is a great guy. He gave us a coupon code to use, DTHA 2019, to use at checkout. You get 10% off your order. Hey guys, Dave the Outstation here. We are going to talk about something different today. It's going to be about ranging a target in yards using a scope that has a mill reticle. Now, when you're doing this, basically you need a few things, right? So you need your scope, obviously. That is either MOA or mills. MOA we'll talk about later, but it's basically the same concept. You just need to change the math a little bit. So using your mill scope, you either have first focal plane or second focal plane. Now most military law enforcement shooters, competition shooters and stuff, they're using first focal plane scopes, and what that means is that the reticle size increases and decreases in correlation to the magnification range, which gives you the kind of most accurate measurements you can when you're ranging scopes. Second focal plane is when that reticle stays the same size throughout the magnification ranges. Some older scopes, or definitely people on budgets, it's definitely a lot cheaper to buy a second focal plane scope and use that for hunting and competition and stuff. But let that be said that there are, or the majority of people are using first focal plane. I use second focal plane mostly because I pretty much use the same magnification for everything, which is 15 power. And at 15 power, with my particular scope, that's when the measurements are correct. So I don't really care if I'm shooting at 100 yards or if I'm shooting at 1,000 yards. I'm still pretty much only using 15 power anyways. So it works for me. I think in the near future I'm probably going to be upgrading my scope, but that's a whole different topic. So let's get into the math, let's talk about the math a little bit more. When you're applying this formula to a target, what you're going to need to know is a dimension of the target at that distance. So this could be anything from, one of my personal favorites is to use car wheels, not the tire, just the wheel part, and those are pretty universal throughout the world, where larger trucks, SUVs and stuff, they've typically got 17 or 18 inch rims, and cars probably have that 16 or 17 inch rims, maybe 16, 15, whatever. It kind of depends on the car, but if you know a little bit about cars, that's a really good one to use. Doorways and windows, they're pretty standardized in the U.S., but if you're using this overseas or in a part of the country where for whatever reason people have really large windows or really small ones, whatever, just know those dimensions. You can use the height of a average person. In the U.S. it's about 6 foot, or 72 inches. You can kind of estimate up or down from there. But if you, like I said, that's subjective as well, and then it changes throughout the world, right? In the Middle East or Asian countries, they're typically smaller or shorter. In European countries and stuff, they're typically a little bit taller. So just know your demographics where you are at. What I like to do is I like to take my dope book when I go out shooting or competing. I like taking down measurements of the targets, and then you kind of know, what size of target you're shooting at whatever range, and then you can kind of confirm your dope, or confirm your distance if you don't have a laser rangefinder. Now, once you have that measurement, right, you need to apply the formula. So it's super easy. What you do is take that target height or width in inches, and then multiply that by 27.77. That is just a math constant. You don't need to know why it is. Just know that whatever inch measurement you have, multiply it by 27.77, and then what you got to do is measure your target through your reticle. So say you have a 6 foot tall individual, and you measure them at 4 mils high. So you take your trusty calculator here, and you are going to get about, let's see, 72 times 27.77. You're going to get about 1999.44. And then you're going to divide that by the 4 mil measurement that you got through your reticle, and you're going to get 499.86. So, when you're measuring, it takes a little bit of practice, especially if they're non-stationary or you are moving or whatever reason. It does take a little bit of practice to get a really accurate measurement. And this is where first focal plane scopes definitely have an advantage. If you're at a super far distance, you're talking 1,200 meters or 1,200 yards or whatever, something pretty extreme. Your target, if you're shooting at like a 10-inch steel plate, that might not even make it up to the first hash mark in a second focal plane reticle. If you're using first focal plane, you definitely have the ability to play a little bit better with the the target size and stuff. That also, when you're using this, you don't actually have to range your specific target. If you know different target distances in your sector of fire or your field of view for your hunting ground, or the ranges at your target, right? You might not be able to measure that exact thing you're shooting at, but you could be measuring, okay, there's a car, it looks like about 50 yards ahead of where my target is. So I'm going to measure that car, and then I'm going to add approximately 40 or 50 yards on top of that, and your dope probably isn't going to change too much if you're using a good round, depending on what distance you're at. But knowing a little bit more precise measurements are going to give you the most accurate range. But in the shooting world, nothing's perfect. You might be able to see your target or know it's at 500 yards, but there's other stuff that comes into play that's going to throw off your shot more than being plus or minus 10 yards or whatever. There's wind and your stability of the platform you're shooting on. There's the ballistics of the round that you're shooting, et cetera, et cetera. So keep all that in mind. It's nothing compared, or it's not nearly as fast as compared to like a laser rangefinder, but this is kind of expanding your knowledge on shooting fundamentals, getting back to basics and stuff, not relying so much on technology, and especially for hunting and stuff. It's super useful for you guys. If you don't have time to really range that shot and put in the dope in your rifle before that deer runs off or whatever, definitely try this out, practice with it. We are down here at the target. These circles that we're shooting at are 3 inches in diameter, so we will factor that into the equation for the 100-yard mark. So we're going to go down to the 200 yards and measure some steel and see how these line up. Down here at 200, shooting at a steel plate, 16 inches in width. So let's get back, glass it, and we'll see if we can't figure out the exact range from the firing position all the way up there. I can't quite get my camera to line up with the scope and keep the reticle on target, but if you can tell, I'm seeing just about 1 mil at 100 yards, so it's almost exactly 3 inches. It might be a tick below, but let's plug that into our formula here, and we'll see how far it is from the glass to the orange circle out. A 3-inch target multiplied by 27.77, which is 83.31 divided by 1. So according to this, or my measurement, and what I'm seeing right now is that this is not exactly 100 yards. This is going to be about 83 yards. Like I said, it might have been a little bit less than 1 mil, but with my reticle or whatever, I can't exactly measure too much more fine than or a finer measurement than that. So I redid the math. Instead of rounding up to 1.0 mils, I rounded down to 0.8 mils. On my reticle, they are in 0.2 mil increments. So getting there, or using that, I'm a little bit closer to that 100 yard mark. I'm seeing about 2.2 mils, again for that 16-inch square plate on the right. We're going to do 16 times 27.77 equals 444.32 divided by 2.2, and that is almost perfect. So that's 201.96, and that's probably pretty accurate. It's measuring from the scope versus all the way up to the end of the concrete. So that's actually fairly close to what they said it was. All right, we are back from the range. I hope you guys got to see a little bit of how that works. We're double checking, a known distance range at the range that I go to, or range that I have access to right now. It's only 100 and 200 yards, but the principle still applies, or the formula still applies, whether you're shooting at 50 yards or at 1,000. So we got some good practice in, but if you thought this video was helpful, don't forget to like, comment, subscribe. Thank you very much. We'll see you next time.